Congratulations! You are, in fact, a time traveler. While it may not feel like much, you're moving forward through time 1 second at a time. While this sounds mundane, it's the starting point for understanding the more exciting possibilities of real-time travel, the kind that lets you ride with dinosaurs or high-five Einstein. But before we dive into those adventures, let's first grasp how time actually works in our universe. Time, more than just a passing moment. Many of us think of time as something that passes, a steady march forward. But in reality, time is better described as a dimension, similar to the dimensions of space we are familiar with. Our universe, as far as we can tell, is four-dimensional. It combines three spatial dimensions, length, width, and height, and one time dimension into a construct we call space-time. Your life, the experience of time passing, is actually you moving through this time dimension. But unlike space, where you can move forward, backward, up, down, and sideways, time is more limited. In the time dimension, you can only move forward. No detours or going back to relive your youth. Yet, despite this apparent limitation, you have more control over your movement through time than you might realize. Speed through space-time, the universal rule. Here's where things get a bit strange. According to the theory of relativity, everything in our universe moves at the same speed, the speed of light, through the four-dimensional structure of space-time. But there's a catch. This speed is split between the dimensions of space and time. Your speed through space-time is the combined total of how fast you're moving through space and how fast you're moving through time. Even if you're sitting still, not moving through space, you're still moving through the time dimension, crashing headfirst into the future at the speed of light. This means that while you can't avoid moving forward in time, you can change how quickly you do so. By moving faster through space, you can slow down your movement through time. This is a key principle that opens the door to time travel, as we'll soon see. Photons, the eternal present. Let's take a moment to consider light, or more specifically, photons, the particles of light. Photons move through space at the speed of light, as one would expect, but because they are moving at this maximum possible speed through space, they don't move through time at all. From the photon's perspective, time doesn't exist. They are effectively frozen in time. To us, a photon might take 8 minutes to travel from the sun to Earth. But for the photon, this journey happens instantly. Of course, this is a simplification. The real-world physics are more complex, and you can't actually create a reference frame for photons in the way we just described. Still, the concept highlights an important idea. When you move faster through space, you move more slowly through time. At the extreme, moving at the speed of light means no passage of time at all. The wacky world of time travel. Now that we know time isn't as rigid as it seems, we can see how real-time travel might be possible. When a car or bus drives past you, it's moving faster through space than you are. This means it's also moving more slowly through time, relative to you. In fact, everything that moves through space does so at a slower rate through time. The famous twin paradox is a perfect example of this principle in action. Imagine a pair of twins. One stays on Earth while the other is sent into space on a rocket traveling at nearly the speed of light. Because the twin in the rocket is moving much faster through space, they are moving slower through time. When the twin in the rocket returns, they will have aged far less than their sibling on Earth. This paradox may sound like science fiction, but it's a real consequence of the rules of our universe. Time dilation, your personal experience of time. While time dilation, due to speed, offers a theoretical way to leap into the future, you don't necessarily need a rocket to experience time travel. There's another fascinating aspect of time manipulation, and it involves gravity. This phenomenon is known as gravitational time dilation, and it occurs when you're close to a massive object. Essentially, the stronger the gravitational field you're in, the slower time passes for you relative to someone far away from that gravitational source. To explain this concept, let's take an example. Imagine you're standing on the surface of Earth, and someone else is far away in space, well beyond the influence of Earth's gravity. Although the effect on Earth is minimal, time passes just 0.0000007% slower than it would in deep space. Over long durations, this can add up. The closer you are to a massive object, the more extreme the difference in the passage of time becomes. This is a real, observable effect, and not just theoretical. In fact, we experience a minuscule version of this every day. Atomic clocks on satellites, which are farther from Earth's gravitational pull, tick slightly faster than those on the surface. Now, imagine a much more extreme situation. You're near a black hole, one of the most massive objects in the universe. As you approach the event horizon, the boundary beyond which nothing, not even light, can escape, the gravitational field becomes extraordinarily strong. Here, time for you would slow down dramatically compared to someone far away from the black hole. You wouldn't notice anything strange. Your watch would tick as it always does, and your heart would beat at its normal pace. However, to an outside observer, you would appear to almost freeze in time. Days, years, or even millennia could pass outside the black hole, while only seconds seem to tick by for you. This creates a natural form of time travel into the future, albeit one that's difficult to access without venturing near extreme cosmic objects like black holes. While traveling at the speed of light is currently impossible, leveraging the immense gravitational fields of massive objects like black holes gives us another fascinating way to cheat time, at least in one direction: the future. Black holes, the ultimate time machines. Massive objects like planets, stars, and black holes bend space-time, causing time to pass more slowly in their vicinity. On Earth, the effect is incredibly small. Time on the surface passes just 0.0000007% slower than it does far from any gravitational influence. But near a black hole, this effect becomes extreme. Imagine sending your twin to orbit a black hole. The closer they get to the event horizon, the point beyond which not even light can escape, the slower time passes for them. From their perspective, everything seems normal, but from your viewpoint on Earth, they appear almost frozen in time. When they return, they may have experienced only minutes, while years have passed for you. This kind of time travel, while one way, is very much possible according to the laws of physics. Going backwards in time, a glimmer of hope. So far, we've only talked about time travel to the future. But what about going back in time? Is it possible to visit the past? The theory of relativity doesn't forbid the possibility of moving faster than light. If something were to move faster than light, called superluminal speed, it would also move backwards through time. Physicists have even hypothesized the existence of particles that move faster than light, called tachyons. If tachyons exist, they would be able to travel backwards through time. This opens up the tantalizing possibility of sending messages to your past self, preventing past mistakes, or even visiting historical events. However, there's a catch: the energy barrier. Why time travel to the past is hard. Although the idea of traveling faster than light, superluminal travel, sounds exciting in theory, achieving it in reality poses an enormous challenge. The key issue is energy. To accelerate any object with mass, such as yourself or a rocket, to the speed of light would require an infinite amount of energy. Even if we could harness all the energy in the universe, it still wouldn't be enough. This fundamental barrier means that, based on our current understanding of physics, it's impossible for anything with mass to reach or exceed the speed of light. As for tachyons, hypothetical particles that always travel faster than light, they remain purely theoretical. While they work in mathematical equations and offer intriguing possibilities for backward time travel, we have no evidence to suggest that tachyons exist in the real world. No experiment has ever detected them, and their existence remains speculative. In essence, while the concept of moving backward through time or exceeding the speed of light captivates our imaginations, these ideas are confined to the realm of science fiction. Until we uncover new breakthroughs in physics, backward time travel will remain a tantalizing but unattainable dream. The present moment, where time truly matters. So, does this mean time travel to the past is impossible? For now, yes. While we may not have the ability to change past events, we possess the power to influence our present and shape our future. The present moment, right now, is where your true existence lies. It's the most crucial time because it's the only moment you can actively impact. By understanding the nature of time, you can make informed decisions that will enhance your future. Although it doesn't involve physically traveling through time, the ability to shape your future is well within your reach. By acquiring the right knowledge and skills, you'll be better equipped to navigate the challenges and seize the opportunities that come your way. Embracing the present empowers you to create a path that aligns with your goals and aspirations, allowing you to cultivate the future you desire. While the past may be out of reach, the present is your canvas, and your actions today lay the foundation for the tomorrow you envision. Time travel through knowledge. If you're eager to explore more about physics, time travel, or any intriguing subject, Brilliant is a fantastic resource to consider. With thousands of interactive, bite-sized lessons, Brilliant makes learning enjoyable and engaging. Whether you're looking to deepen your understanding of scientific concepts or venture into new areas like data analysis and artificial intelligence, Brilliant empowers you to become a better thinker and problem solver. Additionally, you can dive into topics related to time travel and physics through Kurzgesagt's special partnership with Brilliant. For instance, their course on scientific thinking guides you through the fundamental principles behind some of science's most significant questions. This approach not only enhances your knowledge, but also helps you develop critical thinking skills. By participating in these immersive learning experiences, you can satisfy your curiosity and gain insights that are applicable to real-world challenges. So, if you're ready to embark on a journey of discovery and expand your understanding of the universe, Brilliant is the perfect starting point. A breathtaking time travel adventure. So, while we may not have found a way to break the laws of the universe and travel back in time, there are still plenty of adventures to be had. Imagine traveling through the timeline of human history, seeing the rise of civilization, and witnessing the incredible achievements of our ancestors. If you're fascinated by time travel and want to explore history for yourself, consider getting Kurzgesagt's Timeline of Human History and Timeline of Complex Life posters. They're a beautiful and engaging way to visualize the flow of time and see just how far we've come. Conclusion. In the end, while we may never be able to travel to the past, the future is still wide open. The decisions you make today can have a profound impact on the world of tomorrow. So, embrace the present moment, keep learning, and get ready to shape the future. And remember, if you want to continue exploring the mysteries of time and space, don't forget to subscribe to our channel. With new videos on fascinating topics, you won't want to miss a single moment.